Welcome to Cosmic Compass, where we explore the wonders of space and uncover the stories written in the stars. In today's journey, we'll follow one of the most ambitious space missions ever attempted, NASA's OSIRIS-REx. This spacecraft travelled millions of kilometres, spent years orbiting a distant asteroid, and then reached out to collect a piece of it to bring back home. Why go to all this effort for a small rock in space? What secrets can an asteroid reveal about the birth of our solar system and perhaps even the origins of life itself? Let's find out. When it comes to exploring the universe, poking things with a stick usually isn't an option. We can't poke stars, and planets are far too massive to prod. But what if our stick was $1 billion spacecraft designed to gently tap out a cosmic time capsule? Suddenly, this playful thought becomes one of the most ambitious scientific experiments in history. That's exactly what happened with NASA's OSIRIS-REx mission to Asteroid Bennu, the first time a US spacecraft reached out and physically collected a sample from the surface of an asteroid. OSIRIS-REx, short for Origin Spectral Interpretation, Resource Identification Security, Regolith Explorer, launched in 2016 with a daring goal to bring home a sample from the near-Earth asteroid known as 10M1955 Bennu. Why Bennu? Because this asteroid is ancient. It has existed since the earliest days of the solar system, carrying material unchanged for over 4.5 billion years. Studying it could reveal secrets about how the planets formed and maybe even offer clues to the origins of life itself. Other missions had flown past asteroids, and some had even collected comet dust. But this would be the first time NASA attempted to physically scoop up part of an asteroid's surface and return it to Earth. The target sample was modest, just 60 grams of regolith and dust, but the science locked inside even that handful of material would be priceless. On paper, the mission sounded straightforward. In reality, it was anything but. Bennu is only about 490 metres across, barely half a kilometre wide. Its gravity is so weak that a person could leap off the surface and never come back. Early radar observations had suggested a smooth, sandy surface, perfect for scooping up dust. But when OSIRIS-REx arrived, scientists were in for a shock. Instead of a calm beach of cosmic sand, Bennu looked like a chaotic minefield of massive boulders, some the size of houses. Safe landing zones were scarce, so the spacecraft spent over a year, 505 days, orbiting Bennu, carefully mapping its rugged surface. Eventually, 4 possible collection sites were chosen: Nightingale, Kingfisher, Osprey and Sandpiper. All of them, you might notice, were named after birds. That's no coincidence. Bennu itself was named after a mythical Egyptian heron, and NASA kept the avian theme. After much debate, the team selected Nightingale, a crater that looked relatively young and less cluttered with rocks. Not only would landing be easier there, but its freshly exposed surface promised more pristine material from Bennu's interior. Before attempting the real thing, NASA took no chances. OSIRIS-REx performed practice runs, gradually approaching the asteroid to simulate the maneuver. In April 2020, it descended to just 65 metres before pulling away. In August, it repeated the exercise, this time closing into 40 metres. Each rehearsal built confidence that the spacecraft's thrusters and navigation systems could handle the delicate task. Step by step, OSIRIS-REx was preparing for its boldest move. Finally, on October 20th, 2020, the spacecraft went for it. Because of the time delay between Earth and Bennu, NASA could not control the spacecraft in real time. Everything had to be pre-programmed. OSIRIS-REx adjusted its solar panels into a Y shape to shield them from debris. Its robotic arm, the TAGSAM, extended forward as the craft drifted down toward Nightingale Crater. It touched the surface, and then unexpectedly it kept going. What looked like solid ground was anything but. Bennu's surface was more like a sponge, a fragile mix of rocks and empty voids loosely held together by microgravity. OSIRIS sank half a metre into the asteroid before firing its nitrogen gas burst. In that instant, 6 tons of material erupted outward, far more than expected. Imagine trying to scoop a handful of flour only for the whole bag to explode in your face. That's what happened on Bennu. OSIRIS's thrusters roared, pulling it away from the growing cloud of debris, and when the dust settled, the spacecraft had done its job. Not only had it succeeded in collecting a sample, it had gathered far more than planned. Instead of 60 grams, it captured somewhere between 400 grams and over a kilogram. There was just one problem. The bounty was so great that a small rock jammed the sampler's lid, causing some particles to leak into space. For a tense few days, NASA scrambled to secure the container. Eventually, the sample head was sealed safely inside the return capsule. The mission's greatest risk had turned into a stunning triumph. OSIRIS-REx then circled Bennu to assess the damage. The surface was scarred by a fresh crater, with boulders and dust flung meters away from their original positions. In a single touch, humanity had altered a world that had remained untouched for billions of years, but the spacecraft could not linger. Its precious cargo needed to return home. On April 7, 2021, OSIRIS-REx made one final flyby of Bennu before beginning its journey back through the void. The return trip would take more than 2 years. If all went to plan, by September 2023, the spacecraft would release its sample capsule, sending it plunging into Earth's atmosphere. It would land in the Utah desert, where scientists would retrieve it and begin unlocking the secrets held inside. For the first time in history, a pristine piece of an asteroid would be delivered to Earth, untouched, unspoiled, and ready to reveal the story of our solar system's birth. You might think the mission ended there. But OSIRIS-REx was not finished. After delivering its sample, the spacecraft had fuel left for another assignment, its new target Apophis, a 370-metre asteroid that will pass within 50,000 kilometres of Earth in 2029. In cosmic terms, that's practically brushing past our planet. Like its Egyptian namesake, the serpent of chaos, Apophis, has stirred public imagination as a potential threat, and OSIRIS, now renamed OSIRIS-APEX, the Apophis Explorer, will be there to investigate it up close. It will once again fire its thrusters, stir up surface material, and help us understand an asteroid that will come closer to Earth than many satellites. The mission continues pushing the boundaries of what we can learn from these wandering relics of the solar system. So what began as a spacecraft poking a rock with a robotic arm has become one of humanity's most daring adventures. OSIRIS-REx not only touched an asteroid, it brought a piece of the early solar system back to Earth, and soon it will set its sights on Apophis, taking our exploration even further. Perhaps its greatest discoveries are still ahead. As we watch these missions unfold, we're reminded of a simple truth: each asteroid is a time capsule, waiting patiently for us to open it. And when we do, we don't just learn about rocks in space, we learn about ourselves and our place in the cosmos. And that brings us to the end of our journey with OSIRIS-REx, a mission that not only touched an asteroid but changed the way we understand our cosmic neighbourhood. From Bennu to Apophis, the spacecraft's story is still unfolding, and with every new chapter, we take another step closer to understanding where we come from and where we are headed. If you enjoyed this exploration, join us again here on Cosmic Compass, where together we'll continue to navigate the mysteries of the universe. Until next time, keep looking up, because the cosmos is always waiting to be discovered.